This is proof number 6 from the Chapter 3 review. If you take a look at the givens, they tell me that DG is congruent to JF, and so that's a full segment here, and that's a full segment there, so somehow or another we want to mark that those two full segments are congruent to each other. DE is congruent to JH, so I'll mark those two lower segments on that triangle congruent. And EG, which is this segment here, is congruent to HF, which is that segment there. So we've got those overlapping segments equal to each other, all right? They want me to prove that triangle HCE, which is the big triangle, is isosceles, all right? So remember, we have two definitions of isosceles. We have basically the definition that says you have two congruent sides. We also have a new definition that says that you have two congruent angles, and it seems like that's been happening a little bit more often in these proofs. So typically I'm looking for two congruent angles first, and then, you know, if I need congruent sides, I can go back and do that. The big thing that jumps out at me here is these two triangles appear to be congruent, and if you notice, I've already labeled all three pairs of sides congruent in the given. So they just kind of handed me congruent triangles. Now you do want to make sure that those actually get into your proof, but hopefully everybody can see that. And if you don't see it, you can draw those triangles separately. For example, I've got JHF here, and if you look at my markings, we have that side and we have that one, and we have that one. And so anyway, it is a side, side, side. We have that with the given. So I'm gonna go ahead here and say that triangle JHF is congruent to triangle DEG, and that's going to be by the side rule. And all right, at this point, we're almost done. All I need is two congruent sides or two congruent angles. Now be careful. Sometimes people think, oh, I've got two congruent segments, I can add these segments and get two congruent sides. But remember that the addition property says you have to add congruent segments to congruent segments, and we don't have anything telling us that those two upper segments are congruent to each other. So no addition property here. But look at the lower angles. This angle here is an angle of the triangles that I proved congruent a minute ago. This angle here is an angle of the two triangles I proved congruent. That'll give us the two base angles of this big triangle congruent, and that's all we need to say that a triangle is isosceles. So I can go ahead and say that angle H is congruent to angle E because corresponding parts of congruent triangles are congruent, and we've got a triangle with two congruent angles. It's isosceles. So I can close it out. Triangle HCE is isosceles. Reason being, if a triangle has two congruent angles, then it is isosceles. So pretty quick proof there if you notice that they're basically handing you congruent triangles.